The morning of July 10th, 1944. Saint-Jean-de-Daillé, France. 6 freshly delivered M4 Sherman tanks sat beside the headquarters company of the 743rd Tank Battalion, their turrets marked with a distinctive rounded mantlet that enclosed something the German defenders had never encountered before. These weren't the standard 75mm gun Shermans that had landed on Omaha Beach 5 weeks earlier. These carried 105mm Howitzers, artillery pieces mounted inside tank chassis, capable of firing high-explosive shells with devastating force. The crews gathering around these machines had no idea they were about to deploy a weapon system that would redefine how Americans cracked German fortifications. They certainly didn't know that German engineers, despite years of meticulous planning and millions of tons of poured concrete, had designed the Atlantic Wall to stop tank guns, not mobile field artillery operating at direct fire ranges. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The Atlantic Wall stretched over 5,000 kilometers from Norway to the Spanish border, a defensive network Adolf Hitler had ordered constructed through Führer Directive No. 40 in March 1942. The concept was simple and brutal. Make any Allied invasion so costly, so bloody, that it would be defeated on the beaches before troops could establish a foothold. The math seemed to favour the Germans. Defending forces always held advantages. Attackers needed overwhelming numerical superiority to overcome prepared positions, and the Atlantic Wall represented the most extensive fortification project since the Maginot Line. Organisation Todt, the massive construction agency named for its founder Fritz Todt, drafted over 600,000 French workers to build permanent fortifications along the Dutch, Belgian, and French coasts facing the English Channel. The scale was staggering. Plans called for 15,000 heavy bunkers to be completed by May 1st, 1943. That target proved impossible. By D-Day, June 6, 1944, approximately 6,000 bunkers stood completed, but even this reduced number represented an engineering achievement of intimidating proportions. The bunkers followed standardized designs called Regelbauten, tested and proven during construction of Germany's West Wall fortifications in the late 1930s. German engineers had calculated the precise thickness of reinforced concrete needed to resist various weapons. The construction specifications were explicit. Category B standard bunkers required walls at least 2 meters thick, capable of resisting almost any direct hit from field artillery or tank guns. The most heavily fortified positions, protecting critical gun emplacements and command centers, featured concrete walls up to 3.5 meters thick, with some specialized installations like Battery Lindemann near Calais protected by casements 4 meters thick. These weren't simple concrete boxes. German fortress engineers designed multiple bunker types for specific functions: observation bunkers with armored vision slits, command bunkers with communication equipment, fire control system bunkers for directing artillery, gun casemates with carefully calculated fields of fire, munitions storage bunkers built to survive near misses from heavy bombs, personnel shelters, even specialized toilet bunkers. The H-667 gun casemate, typical of installations along the Normandy coast, featured a garage-like design with a large armoured access door in the rear and a wide embrasure in the front, opening a 60-degree field of fire. Construction of the H-667 bunker required excavating approximately 150 cubic meters of soil and pouring 380 cubic meters of concrete onto 17 tons of steel rebar and 4.5 tons of additional steel framing. Almost 150 bunkers of this type were constructed on the Atlantic Wall in early 1944, with more than a third in Lower Normandy under control of the German 7th Army. Those armed with 88mm guns were particularly lethal. The concrete walls were Category B standard, 2 meters thick, designed to defeat any Allied tank gun or towed anti-tank weapon then in service. German calculations were based on known Allied weapons. The American 75mm tank gun, firing standard armor-piercing ammunition, could not penetrate 2 meters of reinforced concrete at any practical range, British 17-pounder anti-tank guns, the most powerful Allied anti-tank weapon deployed in meaningful numbers, likewise lacked the punch to breach properly constructed Atlantic Wall fortifications from direct fire. The Germans built these positions specifically to channel attacking forces into kill zones where pre-registered artillery and interlocking machine gun fire would tear them apart. Every bunker was positioned to provide mutual fire support. Every strong point, called a widerstands nest or resistance nest, consisted of multiple bunkers arranged so that attackers could not approach one position without exposing themselves to fire from others. The larger Stützpunkte, or support points, incorporated numerous resistance nests into coordinated defensive networks covering key sectors of coastline. In early 1944, Field Marshal Erwin Rommel, assigned by Hitler to inspect and improve Atlantic Wall defenses, recognized that the existing fortifications were entirely inadequate for the invasion he knew was coming. Rommel had fought British and American forces in North Africa. He had experienced Allied air power firsthand and understood its devastating effectiveness. He feared that any German counterattack would be broken up by Allied aircraft long before armoured. Reserves could reach the beaches to drive invaders back into the sea. His strategy was straightforward: destroy the invasion at sea if possible. If attackers reached the beaches, destroy them there. Under no circumstances allow Allied forces to establish a secure beachhead and bring their overwhelming material superiority to bear inland. Under Rommel's direction, hundreds of additional reinforced concrete pillboxes were built on beaches or slightly inland to house machine guns, anti-tank guns, and light and heavy artillery. Land mines and anti-tank obstacles were planted on the beaches. Underwater obstacles and naval mines were placed in waters just offshore. The defensive philosophy was clear. The Atlantic Wall bunkers were designed to resist bombardment from naval guns firing from offshore, aerial bombing from Allied aircraft, and direct fire from any weapon the Allies could bring to bear during an amphibious assault. German engineers had run the calculations. A properly constructed Category B bunker with 2-meter-thick walls could survive hits from battleship shells landing nearby. Direct hits might cause structural damage, but were unlikely to achieve penetration. Tank guns and towed anti-tank weapons were essentially irrelevant against such fortifications. The concrete was simply too thick for kinetic penetrators to breach. What German planners had not anticipated, what their calculations had never considered, was a weapon that didn't rely on armor penetration at all. They had designed bunkers to stop shells traveling at high velocity, designed to pierce armor plate through kinetic energy. They had not designed bunkers to resist high explosive shells from field artillery howitzers firing at direct fire ranges, delivering massive explosive payloads that didn't need to penetrate concrete to kill everything inside. The story of how this oversight developed begins not in France, not in Germany, but in Italy during the brutal fighting of late 1943. American forces advancing up the Italian peninsula encountered terrain and fortifications that made a mockery of standard armoured warfare doctrine. The mountainous landscape was utterly unsuited for tank operations. Narrow valleys flanked by steep ridges created natural kill zones where German defenders could destroy attacking forces with pre-registered artillery fire. The Winter Line, centred on the heavily fortified Gustav Line, stretched 100 miles from the Tyrrhenian Sea in the west to the Adriatic Sea in the east. German engineers had transformed the mountainous terrain into a defensive masterpiece, bristling with thousands of artillery pieces, mortars, machine gun nests, concrete bunkers, and minefields. The fieldworks were laid out in multiple mutually supporting lines to maintain defense in depth, each position sited to provide overlapping fields of fire that made approach suicidal. Monte Cassino, the ancient abbey founded in the year 529, occupied the most strategically valuable real estate in Italy by winter 1944. The high ground overlooked the entire Liri Valley and the main route to Rome. German forces had fortified the approaches with exceptional skill. Masonry houses served as bunkers. Anti-tank guns positioned at road intersections stopped American advances cold. Every attempt to storm the heights resulted in catastrophic casualties. American tank battalions attacking these positions faced an impossible tactical problem. Their M4 Shermans with standard 75mm guns could destroy other tanks effectively, but the high-velocity armor-piercing rounds designed to penetrate enemy armor proved largely useless against thick masonry walls and reinforced concrete fortifications. The armor-piercing shells would punch through thin walls but lacked the explosive payload to cause significant damage to defenders inside hardened positions. What American commanders needed was direct-fire artillery support from guns, capable of delivering large, high-explosive shells accurately against point targets. They had such weapons, the M7 Priest 105mm Howitzer motor carriage, but practical experience in Italy revealed fatal limitations. The M7 was built on an M3 Lee tank chassis, with an open-topped superstructure mounting an M2 A1 105mm howitzer. It provided excellent indirect fire support, lobbing shells over hills and buildings to strike targets beyond direct line of sight. However, the M7 was poorly suited for direct fire work at close ranges. The mount was not very accurate for direct fire, and there was no fixing it. The gun sat high in an open fighting compartment with limited traverse and minimal gun depression, making it difficult to engage targets at the close ranges where American tankers were fighting in Italy. More critically, the M7's light armor provided inadequate protection when operating in direct fire roles where return fire was inevitable. The fair 38mm armor plate that protected against shell fragments and small arms fire could not stop German anti-tank weapons. Crews operating M7 Priests in direct fire missions against fortified positions discovered they were trading shells with an enemy who could kill them far more easily than they could destroy prepared defenses. The M7 would fire, its position would be identified, and German anti-tank guns or tank destroyers would return fire with devastating effect. The open-topped fighting compartment meant that even near misses from artillery airbursts could wound or kill crew members. The solution emerged from American automotive engineering excellence and mass production capability. If the M7 Priest's gun was effective but the chassis was vulnerable, mount the same gun in a fully enclosed, better armoured platform. The M4 Sherman chassis provided exactly that: proven reliability, adequate armour protection, and a turret that could accommodate a 105mm howitzer with modifications. Development began in early 1942, when engineers tested the feasibility of mounting a 105mm howitzer in the Sherman's turret. Initial tests on an M4A4E1 platform revealed problems. The basic M2A1 howitzer was ill-designed for mounting in a tank turret, awkward ergonomics within the turret, and an unbalanced turret design where the heavy gun made the turret front-heavy delayed proper testing until February 1943. Engineers completely redesigned the howitzer, redesignating it the M4 105mm howitzer, specifically optimized for tank turret mounting. The new design required extensive modifications. The turret interior needed reorganization to accommodate the larger 105mm ammunition. The gun mount had to be engineered to properly balance the turret and strengthen power traverse mechanisms. The hull layout needed adjustment to store the different ammunition types the 105mm gun would fire. By August 1943, the Ordnance Department approved the project, and 2 pilot vehicles designated M4E5 were completed for testing. These pilots, based on first-generation small-hatch M4 hulls, incorporated all necessary changes. The new lighter combination mount improved turret balance to workable levels. Testing revealed the modifications were acceptable for combat, provided additional changes were made for production models. The Armoured Board, evaluating the pilots, made several consequential decisions. They determined that gyro stabilizers, standard equipment on 75mm and 76mm Shermans, were not required for the 105mm variant. This decision had minimal impact since crews rarely used the gyro stabilizer anyway, finding it overly complicated and of questionable utility. Far more significantly, the board decided that power traverse was not required for this vehicle, due to its intended tactical employment. This decision would haunt American tank crews for months. The 105mm Sherman was expected to provide fire support from relatively static positions, lobbing high-explosive shells at bunkers, buildings, and fortified emplacements. The board assumed crews would have time to manually traverse the turret between targets. They failed to anticipate that combat conditions would frequently require rapid engagement of multiple targets at varying azimuths, situations where slow-hand traverse severely limited effectiveness. Despite these limitations, the urgency was unmistakable. General Gladion Barnes, chief of the technical division of the Ordnance Department, was so anxious to get the 105mm Sherman into production that on April 22, 1943, he recommended that procurement of 1,000 vehicles be initiated without delay. This was months before the M4E5 pilots were even completed, much less tested. Barnes argued that waiting for complete testing would delay the project by at least 4 months and preclude any production during 1943. The Ordnance Technical Committee approved Barnes's recommendation on August 19, 1943, shortly after the M4E5 pilots were shipped out for testing. Production of M4 105mm and M4A3 105mm Shermans was standardized and authorized. Chrysler Corporation received the contract to produce all howitzer-armed tanks. The first production, M4 105mm Sherman, was accepted in February 1944, ready for the Normandy invasion scheduled for early June. The production timeline was extraordinarily compressed. From initial concept in early 1942 to fielded weapons in February 1944 required only 2 years. Remarkable for a weapon system requiring such extensive modifications. This speed reflected American industrial capacity and the desperate urgency of providing troops with weapons that could crack German fortifications without incurring catastrophic casualties. The M4 105mm Sherman that rolled off Chrysler production lines in early 1944 represented a fundamental shift in American armored doctrine. The tank weighed approximately 33 tons, slightly heavier than standard 75mm gun Shermans due to the modified turret and heavier ammunition. It was powered by either the Continental R975 radial engine in M4 variants producing 400 horsepower, or the Ford GAA 8" M4A3 variants, the latter providing 450 horsepower and superior reliability. The crew complement remained 5 men: commander, gunner, loader, driver, and assistant driver, who also operated the bow-mounted machine gun. The 105mm Howitzer M4 dominated the turret, its distinctive rounded gun mantlet immediately identifying these vehicles to anyone who knew what to look for. The gun had a relatively short barrel compared to anti-tank guns, measuring just over 2.5 meters, approximately 22.5 calibers in length. This short barrel was deliberate. The 105mm wasn't designed for high-velocity armor penetration. It was designed to lob large, high-explosive shells with devastating effect. The ammunition loadout reflected this mission. Production M4. A 3 105mm Shermans carried 66 rounds of main gun ammunition in armoured floor and sponson racks. The primary round was the M1 high-explosive shell, weighing 33 pounds and containing approximately 4.5 pounds of TNT explosive filler. This was artillery ammunition, the same type fired by towed M2 A1 field howitzers and M7 Priest self-propelled guns, but now deliverable with the accuracy and protection of a tank platform. The HE shell was semi-fixed ammunition, meaning the projectile and propellant charge were loaded separately. This allowed variable charge increments from 1 through 7, with 7 being full charge. Different charge increments changed muzzle velocity and range, allowing the gun to function in both direct fire and indirect fire roles. At full charge, the M1 HE shell had a muzzle velocity of approximately 472 meters per second, far slower than the 900 meters per second achieved by 75mm armor-piercing rounds from standard Sherman guns. This low velocity made the 105mm Sherman a poor choice for long-range gunnery duels. The slow-moving projectile required significant lead on moving targets and dropped noticeably over distance, demanding precise range estimation and elevation adjustment. But at the close ranges where American tanks were fighting in Italy and would fight in France, typically 300 to 600 meters, these limitations mattered little. The devastating, explosive power of a 33-pound high-explosive shell hitting a bunker or fortified building more than compensated for any ballistic shortcomings. The tank also carried a limited number of M67 heat rounds, high-explosive anti-tank ammunition capable of penetrating armor regardless of range. The M67 used a shaped charge warhead that focused explosive energy into a penetrating jet capable of burning through approximately 5.5 inches of armor plate. This was fixed ammunition, always fired at full charge, with a muzzle velocity of approximately 381 meters per second. The heat round gave 105mm Shermans some capability against enemy armor, though the low muzzle velocity and relatively inaccurate trajectory made it unreliable at anything beyond close range. Additionally, the tank carried smoke rounds for screening friendly movements and white phosphorus shells that could blind enemy optics with burning smoke and potentially force crew abandonment of enemy vehicles when the acrid fumes were sucked inside through ventilation systems. The variety of ammunition types made the 105mm Sherman remarkably versatile, capable of engaging fortifications, infantry, light vehicles, and, in desperate circumstances, even enemy tanks. The organizational structure for deploying these weapons was carefully planned, a standard 1944 U. Army Tank Battalion was authorized 6 105mm Shermans, organized into assault gun platoons. 3 tanks formed an assault gun platoon under Battalion Headquarters Company, with 1 additional tank assigned to each of the 3 medium tank companies. This distribution ensured that every company had immediate access to high explosive firepower while maintaining a centralized reserve that battalion commanders could employ as needed. The 743rd Tank Battalion that landed on Omaha Beach on D-Day had not been equipped with any 105mm Shermans. Their records report that on July 3, 1944, the assault gun platoon received 6 M4 105mm Howitzer tanks. The battalion commander chose to allot all 6 to Headquarters Company rather than distributing them among the line companies. Their first combat occurred on July 10th near Saint-Jean-de-Daillé, when the assault gun platoon in support of Company A fired from battery position, providing indirect fire support like towed artillery. This initial employment reflected uncertainty about how best to use the new weapons. Were they tanks or were they artillery? The answer, as combat experience would prove, was both. The 105mm Sherman could function as mobile artillery, firing from defilade positions at targets beyond line of sight using forward observers to adjust fire. But it could also operate as a direct-fire assault gun, rolling forward with attacking tanks to blast bunkers and fortified positions at point-blank range. The German defenders facing these weapons in Normandy had no comparable system. German armoured doctrine focused on tank versus tank combat and anti-tank defence. The Sturmgeschütz assault guns that had proven effective on the Eastern Front carried high-velocity guns optimized for armor penetration. The Stug 3 mounted a 75mm gun with excellent anti-tank performance but limited high-explosive effect. Even the larger Stug 4 and Jagdpanzer vehicles prioritized armor penetration over explosive payload. German infantry relied on towed artillery and mortars for fire support against fortifications. But these weapons required significant time to emplace, were vulnerable to counter-battery fire, and lacked the mobility to keep pace with armoured advances. The concept of mounting a field artillery howitzer in a fully armoured, mobile tank chassis simply didn't fit German tactical thinking. They had assault guns for direct fire support, but those assault guns were optimised for anti-tank work, not bunker busting. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. This philosophical difference would prove decisive in Normandy and beyond. The Atlantic wall bunkers scattered across the French coastline and extending inland represented the culmination of German defensive engineering. These were not hastily constructed field fortifications. These were permanent installations built to exacting specifications with quality materials when such materials were still available. A typical R501 personnel bunker, originally designed in 1939 for the West Wall and later adapted for Atlantic Wall use, consisted of reinforced concrete walls 2 to 2.5 meters thick. Interior rooms were standardized at 2.1 to 2.3 meters in height. The concrete contained carefully calculated aggregate ratios and steel reinforcement designed to absorb and distribute the shock of near-miss explosions. Emergency exits led to the roof through protected wells on exterior, gas-tight doors and ventilation systems with blast valves protected against chemical weapons. Every detail reflected German thoroughness and engineering precision. The larger H677 gun casemates, designed to house 88mm anti-tank guns, or field guns, were even more formidable. The garage-style design featured massive armoured access doors in the rear and wide embrasures in the front, providing 60 degrees of traverse for the main gun. 2-meter-thick Category B concrete walls could resist direct hits from naval guns firing from offshore. The Germans calculated that battleship shells from the Allied fleet would detonate on impact against such thick concrete, causing surface damage, but failing to penetrate the structure or kill the crew inside. These calculations were correct for naval gunfire and for tank guns. The high-velocity armour-piercing rounds fired by Sherman 75mm and 76mm guns would impact the concrete, penetrate a short distance, and either shatter or ricochet without achieving meaningful penetration. The concrete was simply too thick. Even if a round somehow punched through, the explosive filler in an armour-piercing shell was minimal, designed to cause spalling inside armoured vehicles rather than demolish reinforced concrete. What the Germans had not calculated was the effect of a 33-pound high-explosive artillery shell impacting concrete at close range. The M1HE shell contained 4.5 pounds of TNT explosive filler, vastly more than any anti-tank round. When this shell detonated against or near a bunker embrasure, the explosive force didn't need to penetrate the concrete. The overpressure wave propagated through the embrasure opening, killing or stunning everyone inside the confined space. The blast fragmented concrete around the opening, sending deadly secondary projectiles ricocheting through the bunker interior. If multiple shells struck the same section of wall, the cumulative damage would crater the concrete, each impact weakening the structure until catastrophic failure occurred. The 2-meter-thick walls that effortlessly stopped 75mm armour-piercing rounds at high velocity could not indefinitely resist repeated impacts from large-caliber high-explosive shells, designed for demolition work. The first German troops to experience this learned the lesson with brutal finality. American tankers in Normandy, initially uncertain how to employ their new weapons, quickly developed effective tactics through trial and error. When encountering a bunker or fortified building, 105mm Shermans would advance to effective range, typically 300 to 600 meters, close enough for accurate fire. But beyond the range where German Panzer or anti-tank guns could easily engage, the gunner would aim carefully at embrasures or structural weak points. The loader would ram an M1HE shell and appropriate charge into the breach. The gunner would fire. The 33-pound shell would arc across the intervening distance and impact with devastating effect. If the first shell didn't silence the position, the crew would reload and fire again and again. The M4 105mm could sustain a rate of fire of approximately 5 to 6 rounds per minute, slower than standard Sherman guns due to the two-piece ammunition, but more than adequate for methodically destroying fixed fortifications. German defenders inside bunkers experienced the nightmare of being trapped in concrete boxes, while high-explosive artillery shells systematically demolished their positions. The noise alone was paralyzing. Each impact transmitted a thunderous shockwave through the entire structure. Concrete dust filled the air. Lighting failed as electrical systems were destroyed. The blast overpressure from shells detonating at embrasures was frequently lethal, even without penetration, rupturing eardrums and causing internal injuries. Soldiers who survived the initial impacts often abandoned their positions rather than wait for the next shell to find them. The effectiveness shocked both sides. American tank crews had expected to fire multiple magazines of ammunition to suppress a single bunker. Instead, they frequently achieved mission kills with just a handful of shells. German commanders who had confidently relied on concrete fortifications to channel and destroy Allied attacks discovered that their prepared positions could be systematically reduced by mobile gun platforms that could appear anywhere along the front. The tactical implications rippled through both armies. American armored commanders rapidly integrated 105mm Shermans into combined arms tactics. When attacking a fortified village or strongpoint, standard procedure became reconnaissance by fire to identify defensive positions, coordinate artillery and airstrikes to suppress known positions, advance with 75mm or 76mm gun tanks, providing overwatch and engaging any German armour, and bring up 105mm Shermans to methodically destroy bunkers and fortified buildings that resisted lighter weapons. The combination was devastating. German defenders faced American tanks they might damage or destroy with their own anti-tank weapons, but the moment they engaged, they revealed their positions. American 105mm Shermans, protected by screening gun tanks, would then systematically demolish those positions with high explosive fire. The Germans could not hide and could not effectively fight back without exposing themselves to obliteration. This represented exactly the kind of combined arms warfare that American doctrine emphasized. Each weapon system covered the vulnerabilities of others. Gun tanks dealt with enemy armor and provided reconnaissance. 105mm Shermans cracked fortifications. Infantry cleared buildings and held captured ground. Artillery and air support suppressed enemy reserves and disrupted counterattacks. The 105mm Sherman was never meant to operate alone. It was meant to function as part of a coordinated team where each element enabled the success of others. The German response was inadequate because no effective counter existed. They could not significantly thicken bunker walls. Materials and time were insufficient. They could not effectively camouflage bunkers. The positions had to be pre-sighted to provide overlapping fields of fire, which meant their locations were often obvious. They could not abandon prepared fortifications to fight mobile battles. American air superiority and artillery dominance made movement suicidal. They were trapped in a defensive doctrine that assumed concrete would protect them, and that assumption was failing catastrophically. By late summer 1944, after Allied forces broke out from Normandy and began racing across France, 105mm Shermans had proven their worth beyond any doubt. Unit after action reports praised their effectiveness. The 755th Tank Battalion, operating in Italy during the 1945 Spring Offensive, reported that the M4A3, with 105mm howitzer and wide steel tracks and all-around vision cupola, was especially good. Casualties among 105mm Shermans were light compared with those suffered by gun tanks, precisely because they could engage targets from standoff ranges where German anti-tank weapons were less effective. Production numbers reflected demand. Chrysler produced a total of 4,680 105mm Shermans, split between M4 and M4A3 variants. Of these, 2,539 were M4A3 105mm HVSS models with improved horizontal volute spring suspension and wider tracks providing better mobility in soft terrain. These tanks saw service in the European theatre, the Pacific theatre, and continued in use during the Korean War, where their bunker-busting capability remained valuable. The irony was profound and unmistakable. German engineers had spent years designing and building the Atlantic Wall, calculating precise specifications to resist every known Allied weapon. They had considered naval gunfire, aerial bombing, tank guns, anti-tank guns, and towed artillery. Their calculations were sophisticated and largely correct. 2 meters of reinforced concrete could indeed stop all those threats when properly employed. But they had calculated defenses against weapons optimized for armor penetration, high-velocity kinetic penetrators designed to punch through steel plate. They had not adequately considered weapons optimized for demolition, low-velocity, high-explosive shells, designed to destroy structures rather than penetrate armor. This oversight was not stupidity, it was a failure of imagination driven by doctrinal blindness. German armored warfare doctrine, forged on the Eastern Front against Soviet T-34 seconds and IS-2 seconds, obsessed over anti-tank capability. Every weapon system was evaluated primarily on its ability to kill enemy tanks. High explosive capability was secondary. This made perfect sense when fighting mobile armored battles across the steppes of Russia, where tank versus tank combat decided outcomes. It made far less sense when defending fixed fortifications against an enemy who could afford to specialize weapons for specific roles. American doctrine approached the problem differently. American armor theorists understood that tanks would encounter various targets, enemy tanks certainly, but also fortified positions, infantry, soft vehicles, and emplacements. Rather than building one tank that did everything adequately, American industry could build specialized variants optimized for different roles. The 76mm gun Sherman handled enemy armor. The 105mm Sherman cracked fortifications. Both shared the same reliable chassis and could be manufactured on the same production lines with minimal retooling. This production flexibility, this ability to rapidly design, manufacture, and deploy specialized variants represented an industrial advantage that Germany simply could not match by 1944. The German economy was straining under Allied bombing, raw material shortages, and manpower losses. Designing and manufacturing a new vehicle type to counter the 105mm Sherman threat would have required resources Germany no longer possessed. More fundamentally, such a vehicle would have been reactive, addressing a problem that should never have existed. If German engineers had properly considered the threat of mobile field artillery during Atlantic Wall design, they could have specified thicker walls, better overhead protection, or different defensive layouts. By the time 105mm Shermans appeared in combat, the Atlantic Wall was already built. Retrofitting thousands of completed bunkers was impossible. The Battle of Brest in August through September 1944 provided a particularly stark demonstration. The city was designated a Festung, a fortress, one of the most heavily defended ports in France. German garrison commander Lieutenant General Hermann Ramke had approximately 35,000 troops and extensive fortifications, including numerous concrete bunkers, pillboxes, and gun emplacements. American forces from 8 Corps besieged Brest beginning August 25th. The fighting devolved into brutal urban combat as German troops defended every building, every bunker, every prepared position. 105mm Shermans proved invaluable, advancing with pacificwar 5mm Shermans for infantry to blast resistant strongpoints at close range. After each position fell, the tanks would reposition and engage the next fortification. The methodical destruction continued for weeks. The Battle of Brest finally concluded on September 19th with German surrender, but only after the city and its port facilities had been so thoroughly destroyed that the port remained unusable for months. In Italy, the Gothic Line presented challenges even more formidable than the Gustav Line had earlier. German forces withdrew to prepared positions in the northern Apennine Mountains, creating another defensive network of bunkers, gun positions, and fortified villages. The 1945 spring offensive in Italy saw extensive use of 105mm Shermans operating as assault guns. Fifth Army reported that the 751st, 752nd, 755th, 757th, and 760th Tank Battalions, along with the 1st, 4th, and 13th Tank Battalions of the 1st Armoured Division, were all equipped with 6 M4A3 105mm Howitzers. The assault guns served mostly as artillery support during the offensive. From April 5th to May 2nd, 1945, Casualty reports documented 3 M4A3 105mm tanks destroyed and 1 damaged but repairable. Compare this to catastrophic losses among standard gun tanks engaged in the same offensive, and the survivability advantage becomes obvious. The Pacific theatre presented different challenges but similar solutions. Japanese defensive doctrine emphasized prepared positions, bunkers, and fortified caves that had to be reduced one by one. The 105mm Sherman proved ideal for this work. On Okinawa, the final major land battle of the Pacific War, assault guns from the 706, 711, and 763rd Tank Battalions consisted entirely of M4 105mm Shermans, Japanese. Fortifications on Okinawa were extensively prepared. Limestone caves provided natural protection that could be reinforced with concrete and timber. Surface bunkers were carefully camouflaged and sited to provide interlocking fields of fire. Standard tank guns firing armor-piercing ammunition proved largely ineffective against such positions. High explosive shells from 105mm howitzers, however, could collapse cave entrances, demolish bunkers, and kill defenders through blast overpressure, even without achieving direct penetration. The effectiveness of 105mm Shermans created an interesting logistical situation in Europe by spring 1945. Production had ramped up significantly based on field demand, but casualties remained low because the tanks operated primarily in fire support roles rather than frontline combat. By spring 1945, there was a 71% reserve of howitzer Shermans in the European theatre. 82 tanks on hand versus a table of equipment requirement for only 633. This oversupply led European Theatre of Operations headquarters to recommend that further shipments be cancelled. Theatre commanders stated there was reluctance to substitute the 105mm howitzer tank in the tank platoon because of the lack of power traverse mechanism. This complaint, which had been raised repeatedly since the weapons entered service, reflected genuine tactical limitations. Hand traverse was painfully slow, typically requiring 30 to 40 seconds to rotate the turret 90 degrees. The 105mm Sherman was not a main battle tank. It was a specialized assault gun optimized for destroying fortifications. In that role, it excelled. Attempting to employ it as a general-purpose tank degraded its effectiveness and exposed it to threats it wasn't designed to counter. The proper organizational structure, 6 tanks per battalion, employed as assault gun platoons, supporting combined arms operations, maximized strengths while minimizing weaknesses. Captured German after-action reports from Normandy reference American tanks with large-caliber guns engaging bunkers from standoff ranges. German defenders noted that attempting to return fire simply drew more attention. The concrete positions that were supposed to provide protection became death traps once American howitzer tanks began systematically demolishing them. Several reports recommend abandoning bunkers early in an engagement rather than remaining in position to be buried alive under collapsing concrete. The psychological impact was significant. German soldiers who had trusted concrete fortifications to protect them discovered that this protection was illusory against mobile 105mm howitzers. The Atlantic wall bunkers that should have channeled Allied forces into kill zones became targets themselves. This psychological shift undermined defensive morale. If the prepared fortifications couldn't protect them, what could? The answer was nothing. By late 1944, German forces were fighting a purely defensive war with dwindling resources and no hope of strategic victory. The Atlantic Wall had failed to stop the D-Day invasion. The subsequent defensive lines in France had been breached or bypassed. German forces were retreating on all fronts, trading space for time while hoping for some miracle that would never arrive. The 105mm Sherman was just one weapon system among many that demonstrated American material superiority. It wasn't the war-winning weapon. No single weapon system ever is. But it represented American industrial capacity, the ability to identify a tactical problem and rapidly design, produce, and field a solution. From recognizing that the M7 Priest was inadequate for direct fire support in Italy, to producing thousands of specialized assault gun Shermans in barely more than a year, demonstrated an industrial responsiveness that Germany could not match. This responsiveness extended beyond just the 105mm variant. American industry produced 76mm gun Shermans when better anti-tank capability was needed. Jumbo assault tanks with thicker armor were produced for units requiring breakthrough capability. Flamethrower Shermans were built for Pacific operations. Dozer Shermans cleared obstacles. Recovery variants retrieved damaged vehicles. The basic Sherman chassis proved incredibly adaptable, and American industry could manufacture variants rapidly based on field requirements. German industry, by contrast, struggled to maintain production of existing designs, while Allied strategic bombing destroyed factories and transportation networks. The resources required to develop and manufacture a counter to the 105mm Sherman simply didn't exist. Even if such a vehicle had been designed, deploying it effectively would have required fuel that Germany couldn't provide, spare parts that couldn't be manufactured, and trained crews that didn't exist in sufficient numbers. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe. The 105mm Sherman remained in American service well after World War II ended. During the Korean War, these tanks provided valuable fire support against North Korean and Chinese bunkers and fortified positions. The mountainous Korean terrain and extensive field fortifications created tactical situations remarkably similar to Italy, where mobile howitzer fire proved decisive. Today, surviving 105mm Shermans are rare and highly prized by museums and collectors. The Normandy Tank Museum near Catz, France, displays an M4 105mm VVSS Sherman that saw service with Free French forces in 1944. The Bastogne Barracks Museum in Belgium houses another example, serial number 57304, built by Chrysler in June 1944, restored to running condition. The Bastogne Historical Centre displays yet another, serial number 57132, built in May 1944. Each surviving vehicle tells the story of American industrial adaptation. The story of the 105mm Sherman reveals fundamental truths about industrial warfare that remain relevant today. Superior engineering alone cannot win wars if industrial capacity is insufficient. Specialized weapons, optimized for specific roles, often outperform generalized weapons that attempt to do everything adequately. Rapid adaptation to changing battlefield requirements provides decisive advantages. Combined arms tactics that integrate multiple weapon systems covering each other's weaknesses defeat rigid defensive doctrines. German engineers who designed the Atlantic Wall were skilled and thorough. Their calculations were mathematically sound. Their construction was high quality. The bunkers they built could indeed resist the weapons they had calculated against. But war is not a static equation where one side builds defenses and the other attacks with predetermined weapons. War is a dynamic process where both sides adapt, where new weapons are developed to counter new defenses, where industrial capacity determines how rapidly adaptation occurs. The Germans built bunkers to stop tank guns and kinetic penetrators. The Americans responded by mounting field howitzers in tank chassis, creating mobile artillery that could demolish those bunkers at direct fire ranges. This wasn't unprecedented. Assault guns and infantry support vehicles had existed since World War I. What was unprecedented was the speed and scale of American adaptation. From recognizing the problem in Italy to fielding thousands of specialized vehicles in time for Normandy required industrial infrastructure that Germany simply could not match. The individual German soldier in a bunker facing an American 105mm Sherman experienced the war at its most visceral level. The concrete walls that were supposed to protect him became his tomb, as high-explosive shells methodically destroyed his position. He could return fire, but his weapons were optimized for armor penetration and largely ineffective against the tank chassis. He could call for support, but German artillery and armor were stretched thin across multiple fronts. He could abandon his position and withdraw, but doctrine demanded he fight from prepared positions. The American tanker manning the 105mm Sherman had a different experience. His weapon gave him standoff capability to engage bunkers from ranges where return fire was less effective. His armor protected him adequately against small arms and shell fragments. His logistics provided unlimited ammunition, fuel, and spare parts. His doctrine emphasized combined arms cooperation that reduced his individual risk. This asymmetry, repeated across thousands of tactical engagements throughout 1944 and 1945, ground down German defences inexorably. The Atlantic Wall, the Winter Line, the Gothic Line, every prepared defensive position eventually fell to Allied combined arms assault, supported by specialized weapons like the 105mm Sherman. German engineering excellence and tactical skill could delay Allied advances, could inflict casualties, could make the Allies pay for every kilometre gained. But they could not stop the advance because industrial capacity ultimately determined outcomes. The 105mm Sherman's true legacy is not measured in bunkers destroyed or battles won. Its legacy lies in demonstrating that industrial adaptation and specialized weapon development can overcome even the most carefully prepared defenses. The Germans never expected mobile 105mm howitzers because their doctrine didn't contemplate such weapons. This failure of imagination, combined with insufficient industrial capacity to respond once the threat became clear, sealed Germany's fate as surely as any single battle. For the men who designed the Atlantic Wall bunkers, who calculated concrete thicknesses and planned fields of fire, who supervised construction and inspected finished installations, the arrival of American 105mm Shermans represented the collapse of their assumptions. They had built fortifications to resist high-velocity kinetic penetrators. They got low-velocity demolition charges delivered with precision by protected mobile platforms. The math that had seemed so solid, the concrete that had seemed so impregnable, proved inadequate against a threat they had not properly anticipated. The Atlantic Wall bunkers stand today as monuments to German engineering and testament to the futility of static defense against an enemy with overwhelming industrial advantages. Tourists can visit these concrete structures, walk through their interior chambers, observe the thick walls and carefully designed firing ports. The bunkers survived the war largely intact. Many show damage from high explosive shells, cratering around embrasures where American 105mm Shermans concentrated fire. The concrete held, mostly, but the positions fell anyway because the crews inside could not survive sustained bombardment. These ruins remind us that wars are won not by building impregnable fortifications, but by maintaining the industrial capacity to adapt weapons and tactics faster than enemies can respond. The Germans built impressive bunkers. The Americans built weapons to destroy those bunkers. That cycle of challenge and response, played out across the entire technological spectrum of World War II, ultimately favored the side with greater industrial depth and adaptability. In industrial warfare, production capacity and adaptability matter more than individual weapon superiority. 1,000 adequate weapons available now beats 100 superior weapons available in 6 months when 6 months is too late. The 105mm Sherman was available in sufficient quantities when needed, performed its specialized role effectively, and could be supported logistically without strain on American industrial capacity. The Atlantic Wall bunkers built to stop tank guns never expected mobile 105mm howitzers. By the time they encountered such weapons, it was too late. The concrete stood firm, mostly, but the defenders inside could not survive. The fortifications that should have protected Germany's Atlantic frontier became tombs for the soldiers who manned them. This was the cost of doctrinal blindness and industrial inadequacy. This was the price of building defences against yesterday's threats without anticipating tomorrow's adaptations. This was the fate of German defensive strategy in World War II, doomed not by lack of courage or skill, but by insufficient imagination and inadequate industrial depth to match American adaptive capacity. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.